Welcome to the Spot 2.0 software tutorial series. So in this first video, I'm just going to be covering the installation of the software on a new computer. So the latest version of the Spot software is usually stored on SVN. So if you have SVN already set up, navigate to SVN, Tools, Spot Software Repository, and then you have the latest zip file here. So copy this zip file to a location of your choosing, and then extract the contents. Once you've extracted the software, you can see inside this folder there's several different subfolders. We have examples, low-level files, face-based server, projects, useful code, and user manual. So just very briefly, I'll go into more details in another video, but the examples folder contains basic examples on how to use the software. The low-level files contains all of the vital code to run the software. The face-based server contains the Visual Studio project for the face-based server. The projects folder is where new users should store their projects. Useful code just contains some code that may be useful for certain experiments. And then the user manual is self-explanatory. So once you've extracted the software, you want to open up MATLAB, and you want to navigate to the location of the folder. So in my case, I put it on the desktop. So users, Alex, desktop, and Spot software. So the first thing you have to do is you have to add the low-level files to the path. So selected folders and subfolders. Once you've done that, you need to click on Set Path and Save. Once you've properly set up the path for the low-level files, the next thing you have to do is go into low-level files, generate new experiment, and click on the new experiment function. This needs to be customized for any new computer. So the two lines of concern are this one on line 9 and this line on line 11. You need to make sure that the directory here matches the same directory you have it set up as in the computer. So as you can see, if I click on low files, the directory is C users Alex C desktop Spot 2.0 low files, which in my case, C Spot 2.0 low files, it doesn't match. So I have to take this and copy it and just put it here like that. And then the same thing has to be done here. So right up until this point, it needs to match, like so. And that's what you need to do. So you can save that and you can close it. And then we can go back to the main directory. So we're going to create a simple project just to make sure that everything gets installed properly. To do that, you type new experiment in the command window, and you'll receive a prompt. This prompt is where you type in the name of the experiment. So we're going to call it example 0, setup software. By doing this, you've essentially copied a folder with the name that you gave it, and inside should be all of the required files to run an exam. Usually at this point you would change the template name to match your experiment or project title, so in this case it's setup software. And now we need to actually install the stuff that we need. So everything that you need to install can be found in the add-ons. So click on add-ons and it will open up a window. In the Add-ons Explorer, the first thing you want to install is the Raspberry Pi tools for Simulink. So if you search Raspberry Pi, you'll see Simulink support package for Raspberry Pi hardware. So you want to click on this. And since I already have it installed, I don't have it here, but any new users will have the install option here. So click on install and follow the steps up until it asks you to install the Raspberry Pi OS. At which point you can cancel the installation, since all we need is the software on our PCs. You don't need to concern yourself with setting up the Raspberry Pi. So once you've installed the Simulink support package for Raspberry Pi, we have to get the coder for ARM Cortex-A. So the embedded coder support package for ARM Cortex-A. once again, you need to install it, follow the steps. One thing of note here is the requirements. So the Spot software assumes that you're using the Carlton license, which comes with every possible toolbox. But specifically, in order to run this, you need to have Embedded Coder, MATLAB Coder, and Simulink Coder. If you do not have these tools, you cannot use this software. So once this is installed, we've essentially set up everything that we need, and then we can actually test our experiment software. So to do that, the first thing we want to do is open up the Simulink diagram here. So once the Simulink diagram is open, the next thing we have to open up is the Run Initializer script. And we will run this in a second, but first let's make sure that everything was installed correctly. So on the bottom right here, you can see the Control Black electromagnet block. If this block, where it says Raspberry Pi, is not present or has some kind of error block, it means that the Raspberry Pi toolbox was not properly installed. Another place to check is in the Use Hardware to obtain states under red plus black, red states. We can see that the UDP send block here exists, therefore it's been properly installed. So the next thing we want to do is actually try to run something in simulation at least. So in the initializer script, I'll go over this in much more detail in another video, but this is where you set up all of the parameters for your simulation and experiment. So let's just run this. And we can see that we've opened up our GUI. So in step 1, you can select your diagram. We've already opened it, but if you haven't, you can click Open Diagram. Then we have to pick the platforms that apply for our simulation or our experiment. So in this case, we want to have red and we want to have black, and then confirm. So we can see that red and black now show up on our GUI. So everything from step 3, 4, 5, and 6 are concerned only with experiments. We don't need to worry about those right now because we're working on simulations. So the first thing we want to do is run the simulation. So we can see that once we click Run, we could check that it's working by going to the actual Simulink diagram, and we can see that it is compiling indeed in the bottom right corner here. The first time you run this will take a little bit of time. But we can see that it is compiling every function. Now we're initializing and now we're running, so we can see it says waits for simulation to complete. Once this block disappears, it means the simulation is complete, and you'll notice that the play animation and stop animation buttons have been ungrayed, and you can now click on them. However, if you do not pick an animation speed first, you'll receive a little error message, so we have to pick a speed. So usually we want to do 10 times speed just to see that it behaves in a generally good manner. If you want to see how long it will take in real life, you can click normal animation speed. So if I play the animation here, you can see the platforms just move from one position, and then black rotates. And then they move to the center of the table. So you've run your simulation, and now you want to save the data. In that case, you click Save Simulation Data. And you can minimize the GUI and the script. And then you can see the Save Data folder has now been populated with something. So if we open that, we have simulation data and the date and time of saving. So if we click on that, we have a data packet sim. So if I clear the workspace, and I open this up, we'll have our data packet. So inside our data packet, we have our time vector, and we have torque, or force X, force Y, torque for the red platform, position X, position Y, angle for the red platform, and so on and so forth. The actual definition of every column can be found in the user manual. So you can briefly check that it actually did save what we saw in our simulation and just plot this. And yep, we can see that it does indeed move and then move back. So we can close this, we can click our workspace, and navigate back to the main directory. And there you have it. We've basically set up the software, everything's been installed, and we've ran a simulation very quickly to test that everything worked. So now in the follow-up video, I'll go through every one of these folders in detail and kind of discuss the important parts, specifically the face-based server and and the low-level file.